It is going to be day 26, which is Thursday, and I'm doing the video one day early so that I can go ahead and post this up. This is the chapter review for this chapter, and then of course our chapter test is on Friday. So let's look at the review problems. So what I'm doing is I'm only doing a couple of them. I'm not doing all of them from the book. I'm just doing the ones with the math. So I'm going to turn to page 359. And we're going to kind of go over these problems. So we're going to start with question number 2. The question number 2 asks us, what is the 2 ways internal energy of a system increases? And then the way that they do that for is you can either do it by QN or efficiency. And so then you can do the math on both of those, and that's it. Question number 9 is asking you how much work is done on tire volume increases at 3.25 times 10 to the negative 3 meters to 39.47 times 10 to the negative 3 meters cubed. And the pressure is 2.55 times 10 to the 5th pascals. It's asking you atmospheric pressure, work done on the gas. So we're looking for work here. So since we're looking for work here, we're going to take P times VF minus VI. That's what I'm doing here. That's this P here. So let's see if we can do this. Let's do open bracket 255 times 10 caret 5, close bracket, open bracket 4.22 times, whoops, excuse me, up here, sorry, 39.47 times 10 to the caret negative 3, close bracket, oh, excuse me, whoops, subtract 3.5, 35.23 times 10 caret negative 3, and then close it. And so the answer that we have is a negative 1.4688 E5 would be the answer for number 9. So number 16. Number 16 says, heat is added to an open pan of water at 100 degrees Celsius, vaporize the water. The expanding steam that results in 43.0 kilojoules of work. The internal energy of the system increases to 604 kilojoules. How much energy is transferred in the system as heat? So what we're going to be doing here is we're just taking open bracket 604 times 10 caret 3, and we are going to just add that to 43.0 times 10 caret 3 over close bracket. Sorry, I couldn't see it. Okay, I don't know what that was for. And we should have 608 E5. I have a different answer on my paper. Oh, I missed the 3 here. So let's go back up, hit enter, and that's supposed to be 43. So we need to insert, blue insert, 3, enter, and now we get 6.47 times 10 to the 3rd power. 3 plus 3. Okay, so then number 17. Number 17 says a 150 kilogram steel rod is in the building under the construction support of a load of 6,500 kilograms. During the day, the rod temperature increases to 22 degrees Celsius to 47 degrees Celsius. This temperature increases causes the rod to expand and raise the load 5.5 meters. A was to find the energy transfer of heat or from the rod. So A, what we did, is we did, moving this over so I can see it, open bracket 150, close bracket 448, close bracket, open bracket 47, subtract 22, close bracket, enter, and we get 1.68 times 10 to the 6, which I rounded it up to 1.7 times 10 to the 6. B says, for number 17, find the work done on the process at the work done on the rod. So we're going to take our force times our M2 times gravity times D. So that's going to be 650, 9.8, which is our gravity, and 5.5 times 10 caret negative 3. And I got 3.26 times 10 to the second, and I rounded it up to 3.3 times 10 to the second. C says, how great is the change in the rod internal energy? Does the rod's internal energy increase or decrease? So we're going to do 1.7 times 10 caret 6. And we're going to subtract 3.3 times 10 caret 2. And we get 1.69 times 10 to the 6th, which I rounded up to 1.7 times 10 to the 6th. Number 28. It says a heat engine absorbs 850 joules of energy per cycle for a high temperature source. The energy does 3.5 times 10 to the second joule of work during each cycle, expelling 5.0 times 10 to the second joules as heat. What is the energy's efficiency? So for this one, we're going to do our 1 times 5.0 times 10 to the second over to 850, which we're going to get 0.41. Number 29. A gas expands at 606 joules of energy and is added to the heat, and expands the gas at 418 joules of work on the surroundings. What is the overall change of the internal energy of the gas? That is where we're going to take 606, subtract 418, and we get 188 joules. B asked, if work done on the gas is equal to 1,212 joules rather than 418, how much energy would be needed to add to the heat in order to change the internal energy to equal the change in internal energy in part A? So we do 188 plus what we had before, which was right here, 1,212, and that gives 1.400 times 10 to the third joule. So that is the end of the review. So if you will write that down and show me your work and submit it into me, and then on Friday, the only thing you have to do is the test, which of course is going to be due by Sunday midnight. I hope everybody is doing well. I hope that if there's anything I can do to help, please let me know. I think I pretty much got caught up on grades today. I was working on my CP and my honors chemistry and my CP physics and this morning, and got me behind on the video. So I went ahead and made sure, because I have a meeting tomorrow at 8:15. I went ahead and made sure that I did the video today so that you would have it, so that you could go ahead and not wait on me. But I hope you have a good day. Love you and miss you all.